Hello friends, here in this video we are going to see what is meant by perpendicular axis theorem. Perpendicular axis theorem, it states that if Ix and Iyy are the mi, that is moment of inertia, of a given plane figure, then there is also an mi which is perpendicular to the plane figure, and both Ix and Iyy. So this is the statement of perpendicular axis theorem, that if Ix and Iyy are the moment of inertia of any given plane figure, then there is also an mi which is perpendicular to the plane figure, and both Ix and Iyy. So this can also be explained with the help of a diagram, that since if there is a total area capital A, and here we have two mutually perpendicular axes, x and y axis, then there is the third axis which is z, and then there is also mi which is perpendicular to the plane figure, to this plane figure, and even to the two axes. And then I can say that this theorem, it is also called as polar axis theorem, and mi about the third axis, that is Izz, will be equal to Ixx plus Iyy. So therefore the mi about z axis is also known as polar moment of inertia, and polar moment of inertia I can explain it with the help of a diagram. Here we have an example. Suppose we want polar mi of a circle. In that case, here we have a circle having its outer diameter capital D. Here we have x and y axis. Now we know that for a circle Ixx is equal to Iyy, and the value is pi by 64 d raised to 4. We know this from the formula list. Similarly, now if I want to find out the moment of inertia about the third axis, that is z axis, which is perpendicular to this page, or you can say plane, and this axis appears as a point here. So therefore polar mi is given by Izz, or it is also denoted by I suffix p, because it is polar moment of inertia about the third axis. So Izz can also be represented by I suffix p, that is polar moment of inertia, and in some cases it can even be denoted by capital J. So here Izz will be equal to, we know by perpendicular axis theorem, it will be Ixx plus Iyy. So here Ixx is pi by 64 capital D raised to 4 plus Iyy is pi by 64 capital D raised to 4. So therefore Izz will be equal to, this is 2 pi by 64 D raised to 4. So finally I get Izz is equal to 2 and this will get cancelled out. So here I have pi by 32 D raised to 4. So here I can say that this equation A, it gives the polar mi of a circle. Similarly, we can calculate polar mi for each of the plane figures. That is, we can calculate polar mi for a rectangle, we can calculate it for a hollow circle, quarter circle, semicircle, anything. But we have understood from the perpendicular axis theorem that the polar moment of inertia, that is the moment of inertia about the third axis, is the addition of the polar mi of the two centroidal axes. That is, if I add Ixx and Iyy, that is going to give me the value of Izz. So in this video we have seen what is meant by perpendicular axis theorem along with polar moment of inertia.